Good afternoon, everyone. Thank you so much for joining us this afternoon. My name is Carrie Dillon. I'm the Managing Director of the International Textile Alliance, which is the organization that produces Interwoven. And I am very pleased to welcome our guests today from CECLO and from Lenzing. So again, thank you for joining us for today's Lunch and Learn, sponsored by Lenzing Group. We're excited to host a conversation on how natural and engineered fibers are shaping the future of furniture and upholstery through smarter, more responsible material solutions. And thank you again for your partnership and for hosting this lovely event. And now I'm going to turn it over to you.
Great. Thank you, Carrie. Lovely words. So we're going to start with a little bit of introduction, and then we're going to, I have a really nice statement, a few points that SFC, Sustainable Furnishings Council, provided that would be really good to help set the stage on some of these biodegradable or sustainable topics. And then we'll go into each of our technologies, and then we have other facts and figures that help you understand it a little bit better when you go back to, talking with your mills or talking with your customers, et cetera. So brief about me, my name's Walter Bridgham. I work for Lenzing Fibers. We are the leading maker of fibers under the rayon family. So we make lyocell, we make modal, and we also make viscose. Viscose is used a lot in this industry. Our branded viscose is called EcoVero Viscose, and it is 50% less water and 50% less energy to produce it than generic viscose. So that's a good sustainable start up front. And as far as myself, I come from a long retail background, working for Macy's for 33 years, working for a mill after that that used to produce in the US and also sources from overseas. And I've been with Lenzing Fibers for 7 years now, really talking all home products from floor to ceiling, as far as what it brings to not only the environment, but to the end consumer's comfort level. So that's me, and I'd like to introduce Cheryl.
Good afternoon, everyone. It's a pleasure to see you. I hope you please continue to eat your lunch as we go into our Lunch and Learn. That's why it's a Lunch and Learn. I'm Cheryl Smyer, and I'm the Vice President of the Advanced Materials Division of Parkdale. Some of you may be familiar with Parkdale. We're a 110-year-old company this year, privately owned, based in Gastonia, North Carolina. And at some point or another, to a lot of you that are manufacturing textiles, we have supplied you in one way, shape, or form. But my background, a little bit about my background, I've been in the textile industry 32 years. Every year that I've been out of college, it's all been textiles. And when you find a passion for what you do and you enjoy it, it really, as they say, is not work. And in the recent 8 years, I have led the Advanced Materials Division, where we are developing polymer and fiber technology. We found that there was very little innovation in the space of the synthetic fibers and synthetic yarns that would really truly be sustainable outside of the true raw material source. And so we took it upon ourselves to hire a group of polymer chemists and create the next generation of truly sustainable fibers and yarns. So that's what I do and what I enjoy doing every day.
Great. Thank you, and thank you for joining us with this. It covers both the natural side as well as the synthetic side as far as solutions. I'm going to go into a few points from the Sustainable Furnishings Council. I'm not sure if everybody knows who they are. It's an organization that was developed 20 years ago here in High Point, focused on the furniture industry, that has a mission to help furnishings and textile industries reduce their environmental impact. Cascal, which is the bigger organization for sustainability, made an acquisition of most of their assets. So now they are part of Cascal, so they have a bigger reach and better information backgrounds to pull and support you guys with. And their focus is to combat climate change and support decent work for all. And a couple of their trending points that they offered to share. Material choices matter. The industry's biggest opportunity for reducing carbon emissions, up to 80% of products' impact, is locked in at the design and sourcing stage. If we want different outcomes, decisions have to be made in the first few steps. So that's pretty obvious, but it's really important. Another one is a material or product cannot be labeled as sustainable if the people behind it aren't protected. So that, very important. Our workers, safe environments, all those things are important to the sustainability of not only the product, but how the product's made. And then the last one is alignment is what turns ambition into scale. With shared frameworks like Pascal's impact pillars, support decent work for all, and combat climate change, and the SFC's Sustainability 6 focuses now a shared vision to scale sustainable materials across the industry. So keep them in mind as far as Sustainable Furnishings Council as a resource, as well as us being resources for you. With that, I'm going to start into what tencel or our fibers are, and then get to the sustainability part. So we are a wood-based rayon man-made cellulosic fiber, so MMCF or man-made cellulosic fiber. Some of the misconceptions: is it only eucalyptus or is it only beech? No, it's a blend of hardwoods. Spruce, pine, eucalyptus, beech, etc., all as a blend because it's better for the environment. You're not growing one particular species in an environment which is not good for biodiversity. So sourcing these from sustainable forests, sustainably managed forests in a blend works best as far as not only the chemistry, but also good for the environment. So that's the wood here. We chip it. 100% of the wood is used. 40% is the dissolving wood pulp that we use. 10% are sugars and vinegars that we sell to the food industry for chewing gum and pickling. And then the other 50% is biofuel that we use to run the plant. So that's another great thing. 100% of the wood is used, no waste. Then you take this dissolving cellulose pulp, and we blend that with eco-friendly solvents and water and extrude it through spinnerets. So to create this lyocell fiber. So this is from nature. We capture those eco-friendly solvents of water greater than 99%, so nothing goes out into the environment. And then the product itself really goes into everything. So intimate apparel, denim, like the Levi's jacket I'm wearing here, the pants I had on yesterday. So the great things about it for this industry is the moisture management. So there's a super absorbent as far as heat and humidity. So we know in furniture, when you sit on a polyester, no offense, but polyester chair, it can get hot. Your seat and your back, taking naps on your couch. So with blending in our fibers, it helps pull the heat and humidity away. We also have fill fibers that can be used blended inside of the couches and mattresses, etc. So that's another deeper solution for making more comfort for the consumer. The other attribute to it is it's super soft, has great drape, so when you put it into a upholstery fabric, it just immediately adds the softness to it. Takes dye really well. Unfavorable environment for bacteria growth because it absorbs all the humidity to the inside of the fiber. And unfavorable environment for dust mites as well, which is another thing in this industry. And there was one more big one. Oh, biodegradable, compostable at the end of the day. So, which is what we're really going to go into a little bit deeper about what that is. Our fibers biodegrade over 8 to 12 weeks in the natural environments of industrial compost, home composting, industrial composting, freshwater, saltwater. We've done plenty of tests with certified with TUV Austria, which is the leading certifier for biodegradability, as well as a study with Scripps Institute in San Diego, where we compared organic cotton, conventional cotton, poly blends, and our fibers, and which ones went away first. The man-made cellulosics went away first, and then the cotton, and then obviously what stayed was the poly, where Ciclo comes in. for that solution. So that's what our fibers are, what we do. They can be used in all fabrics at different levels. The brand, the consumer really recognizes the Tencel brand that we use for lyocell and modal. Probably most of you are familiar with it as far as when you go apparel shopping. You see that hang tag, you know what you're buying, you trust what you're buying when you see that label, and you trust brands that are using those materials that are recognizable. So that's what I wanted to say about our fibers and how they're used in everything for home textiles, and it's a great solution for the environment. With that, I will turn it over to Cheryl to talk about the Cyclo.
Thank you, Walter. You really teed that up well. We traditionally think about natural fibers originating from organic matter, right? Including eucalyptus and wood and birch and others. Synthetic fibers don't have the capability to quickly biodegrade. So as a yarn manufacturer and a textile company, we became increasingly concerned about the impact of synthetic materials in the environment. We were, at the time, producing somewhere around 12 million pounds of yarn a week, going into all types of mostly apparel applications, some home and other textile furnishings, automotive and technical textiles. But we became aware of the impact of microplastics in the environment as it relates to synthetic textiles. One statistic that honestly stopped me in my tracks was that 35% of the microplastics in the ocean derive from synthetic textiles. Not from plastic bottles, not from tires, not from city dust, which are the other top contributors or offenders, if you will, but synthetic textiles accounts for the largest contributor of pollution. And I was like, how can this be? We need to look at it from the material level. We have to engineer it from the start. And there's a lot of effort, NGOs that are trying to collect ocean plastic, and there's a lot of ocean-bound plastic that's now being used back into textiles. But here's the crux of the matter. Microfibers, which are defined as anything that's 5 millimeters or shorter in length, cannot be captured. You can't go out there with a fishing net and bring all this plastic together and somehow capture it and recycle it and do something with it. They're there. And polyester and nylon and acrylic and polypropylene and the olefin family, all of the synthetic family of textiles, these materials, their polymer structure is so complex that their nature, microorganisms, are not capable of breaking these polymers down. For an example, cotton and man-made cellulosics have a polymer structure of somewhere around 7,000 to 9,000 molecules in length. I'll get a little sciencey, geeky here. Polyester and synthetic materials exceed 100,000 molecules in that polymer chain. So if you are a microorganism that lives in the environment, you just cannot break down synthetic materials. That's why we created Cyclo. Cyclo is an additive that is embedded into the extrusion process of making the staple fiber or the filament yarn. It has to be embedded within the molecular structure so that it has the capability of breaking down. It is not a topical treatment, because a topical treatment would eventually wash out or would lose its efficacy over time. But it has to be embedded at the molecular structure. So that's what we embarked to do. Our first, I would say, soiree at it, we biodegraded it so fast we turned it into powder within contact with water. We're like, okay, well, that's not gonna work for a durable textile. That may be good for a non-woven wipe or, a baby wipe and those kind of disposable materials, right? But for a durable textile, the number one thing that was important was durability and performance. Why do we use so much polyester in this space, and as well as apparel and other textile industry? We use it because it's affordable, because it's available, because we can introduce a lot of different chemistry and technology to give it different attributes that we love, like moisture management, temperature regulating, anti-odor, antibacterial. And so we embarked down this path of developing Ciclo. It's been commercialized now since 2018, so we are marching into our 9th year. And bringing an innovation to the market, such as a biodegradable synthetic, has been a tremendously educational journey. I remember, and many of you in the room, when recycled polyester from plastic bottles first became a thing. And I remember, my son is 23 now, but when he was a baby, I'm like, I would never put my child in a recycled polyester blanket. Like that concept of a dirty bottle was just like, oh, I don't know. How far we've come, right? Recycled polyester is commonplace. But we have to take it a step further, because whether you're working with a virgin material, virgin polyester or nylon or other polypropylene ethylene for cooling, these materials shed microplastics, whether they're virgin or they're recycled. And so we had to address the problem of microplastics at the source.
And they did. Thank you, Cheryl, for that description on that and really explaining what the problem is as far as microplastics, biodegradability. One thing I do want to add to it about recycled polyester, just want to be really clear, that's a one and done. That polymer can, and Cheryl can speak to this more, but that polymer doesn't break, it can be broken down again, but it can't come back in the same format to be able to use in a textile. So recycled polyester was a great thing to start, but really moving to something that's more biodegradable is really the evolution of where things are going to go, because that polyester recycled is still going to be in that landfill for 200 years. So just wanted to point that out.
Yeah, great point.
I have some other interesting things that we found. It's really about core public perceptions of biodegradability and what it means to them. And I have 5 things, and one of these probably resonates with you as far as what you think as far as biodegradability. It breaks down naturally on its own.
It does not.
It's automatically eco-friendly.
It isn't.
Biodegradable equals compostable.
Definitely not.
It disappears quickly.
No.
It's biodegradable. If it's biodegradable, disposal doesn't matter.
Ooh, that's a scary one. Thank you, Walter. So, Walter planted these ideas around what biodegradability is. So, I'd like to share the facts, right? What is biodegradability? So, when we think about, and many of you are producing fabrics or have products that, let's say, are out for outdoor furnishings. And UV exposure, UV protection is a huge factor. I remember seeing movies, and maybe not necessarily my family, but when clothes used to be hung on a clothes hanger to dry, right, in the sun, over time, that becomes an issue. It is a mechanical degradation. It is a truly breaking down and fracturing of that fiber over time due to environmental exposure. But it's a mechanical breaking down. Its resistance reduces, its color gives way, etc. Biodegradation is a biological degradation. It has to be initiated by microorganisms or living organisms that are converting that solid state product, right, let's say a fiber, into a gas and into biomass. That is the definition of something that is biologically degradable. As I mentioned earlier, polyester and synthetic materials, without our technology, would be in the environment over 150 years, way past the time that any of us will be here on Earth. And unfortunately, accumulating at alarming rates for the next generation. So, I think in the 50s, 1950s, really polyester began to grow and continues to grow at a very fast pace. 65% of all textiles produced around the world are made from polyester, 65%. And the statistics show that the increased rates of production into the next 10 years is at the pace of 7 to 8%. So we have a problem, and we're going to keep adding to the problem unless we do something about it. With cyclotechnology, we're transforming the ability for that polyester to be fully biodegraded in under 4 years. So as a
How many years?
4. As a comparison, Walter shared that their man-made cellulosics will biodegrade in 18 to 24 weeks.
8 to 12 weeks.
8 to 12 weeks, thank you. Cotton typically biodegrades in around 6 months, 6 to 9 months, depending on the environment, depending on the dyes and chemicals and finishes. It's really nature. How quickly things biodegrade depends on nature and the environment in which they are in. Materials are not inherently able to biodegrade on their own unless there's an external circumstance that affects it. So when we went to the drawing board with our technical team, we said performance, durability, biodegradability similar to a natural fiber. So wool, linen, flax, those are very coarse, very strong fibers. They biodegrade in around 3 to 4 years. So we said, let's hit that timeline, but let's create a technology that's affordable, that's scalable, performance is not compromised, and it'll biodegrade in under 4 years. So that's what we were able to accomplish. And so a couple of things. Let's say I have a cotton outfit on.
My pants.
Okay, let's say your pants. They're probably 100% polyester with some spandex.
Yes.
If those pants contain cyclo, and hopefully one day they will, Walter, they are not capable of fully biodegrading while they're being produced, while they're being washed, while they're being stored, or if you leave them in your suitcase for a year and forget them, they're not going to biodegrade there. Just like your favorite cotton shirt or cotton denim or linen, these beautiful linens that we see out here, they can't biodegrade just hanging, right? They have to be in a landfill, or their microfibers need to shed into the ocean or areas where materials can biodegrade. Same thing with the cyclotechnology. The inherent property of biodegradation is something that, as we think about designing materials for the future, is really something to consider. April 2nd, some of you may have heard, the HHS and EPA declared a war on microplastics. They actually did. They publicly announced, Secretary Kennedy and Representative Zeldin, who leads EPA, they're like, wow, microplastics is a problem. It's a human health threat. It's already a marine threat. So the U.S. has actually, at the federal level, dedicated about $144 million to understand the impact of microplastics in human health. So we are seeing a movement at the federal level already going in that direction to understand the problem and hopefully address it at the source. The other piece of this is SB 707. So Senate Bill 707 in California, any of you that are selling any product in California must be very in tune of what's coming down the line and the responsibility that's going to be required by your companies or the retailers selling in California. In addition to having the recyclability of the product and the recycling infrastructure to support the collection, the sortation, and the recycling of those textiles, the bill has a provision which requires addressing microplastic pollution. Federal, California. The same bill is being read in Washington and New York, also in Colorado. So there is a certain level of textile responsibility that if we're thinking in the next 3 to 5 year window, there will be a regulatory component that will definitely impact all of us in this room. In terms of Europe, and some of you do business in Europe or globally as well, Europe is actually farther ahead than we are here in the US. Their EPR regulations also have provisions to address microplastic pollution. So it is a problem. Our industry is a contributor, but at the same time, our industry has solutions to address those at the core.
Great. I love that. I think I want to tag on to something that you said about the growth of the fiber basket and how it's going to shift. So when we refer to fiber basket, that means all the materials, the textile fibers that go into making any textile. So 63% we know is polyester, 23% is cotton, 6 to 7% is man-made cellulosics, and then the smaller are your silks and your wools, et cetera, animal products. So the interesting thing, over the next 10 years, there's going to be a shift in that, and the shift is going to become because of population growth. So you think about that. If there's more people, you've got to do a couple things. You've got to feed them. That means you have to grow food. What main crop is used in agriculture? We know it's cotton. So what's going to happen there is it's going to be more profitable for farmers to grow food than it would be for cotton. So you won't see cotton grow as much over the next 10 years to satisfy its population, because the growth will shift to agricultural products as far as food. The man-made cellulosics will pick up some of the need. It's about 30 million tons that's going to be the need over the next 10 years. That's greater each year. So man-made cellulosics is expected to grow 20% above the 6%. So that's why we're here mentioning this one as a solution. But the polyester is going to grow the most significantly. And that's why this is so important to have these conversations now, is setting everybody up for our next generation and our generation after that. So really the decisions now, and knowing these technologies that can help you get there, can make an impact in your products, your business, and your own families. So I wanted to mention that about the fiber basket and how it's going to be shifting over the next 10 years. Something to keep in the back of your mind. And then the other thing I wanted to cover from my side is brands and retailers. What's happening with them? So since I cover other categories outside of furniture and, we know mattresses are really a driving force for sustainability and solving that problem as far as a mattress going into a landfill. How do you make more sustainable materials? How do you get rid of the different parts and components? So they're addressing that. Then you think about the retailers, Williams-Sonoma, Target, Walmart. All of those companies have their own sustainability reports. And if you're doing business with any of them, any of these majors, I highly recommend that you go to that page on their website and learn what direction they're giving, pushing down through their organization. So Target, very heavily penetrated in Cyclo adoption, Tencel adoption, less regular polyester and less recycled polyester. So why is that? Because it helps meet their sustainability goals, their CO2 footprint, et cetera. Same for Walmart. They have, for all their private brands, they've got goals as far as what % they want to shift to more sustainable polyester or to more sustainable cottons. And then the same for the Williams-Sonomas, who are really, really leaders in bringing sustainable products using the FSC certification and the different certifications that they're bringing through. So your brands and retailers are driving this. The furniture industry may not be hearing it as much yet, but it's coming because it's coming in the other worlds. So that's something we just want to, in this environment, this arena, be prepared, know what our options are. We can design into the options and, be that much further ahead.
Indeed. And and really bringing to market materials that are traceable, that are trusted, that are tested. That's really table stakes at this point. Bringing an innovation to the industry, it has to be proven, it has to be traceable. If the brand or the retailer is going to get behind a technology, they have to verify that it's in the product, right? And that it can be tested to their rigorous requirements. So I think one important aspect of our technology, the Cyclo technology, is that it contains a tracer. It is an element that is really detected through an XR fluorescence device. So similarly to an X-ray, right? And so we can detect it pretty quickly. We know how much is in it. We know, first of all, we can verify that it is in it. And secondly, that we know exactly how much is in it. Because in order for the material to be able to biodegrade in the 4 years that our target is, we know how much has to be embedded within the polymer, and we actually dictate how much has to be embedded in the polymer so that the retailer can make claims at the consumer level around how it performs. And so traceability and making sure that the supply chain is held to that.
Yeah.
Absolutely.
Yeah. Lenzing, the same thing. We put a tracer in all of our branded fibers. We can always identify it. It's a way that we confirm, like the mills would have to submit fabric. We test it, confirm it, issue a certification to it. Then you can ask that mill for the certification that goes along with that. And if you wanted to use the Tencel brand, you use a product license, which is free, and it ties everything together. Like the yarn, so we know what yarn was used, we know the fabric meets the requirements, and you're getting what you're buying. So all those transparency, traceability things where we're either FSC certification pulling through, OCOTEX pulling, all these certifications are important, but you want the transparency, but traceability as well. So these companies, these technologies, we're ahead of the game. We already have our own built-in transparency and traceability aspects.
Absolutely. And as we prepare for what's coming down the line with the Materials Matters standard from Textile Exchange, which will essentially take effect in 2028, the first phase of it, where GRS certification and RCS certifications, those are going to be folded into the Materials Matter standard from Textile Exchange. So if you guys, I would encourage you to go to the Textile Exchange website to learn from them, because in the coming 2 years, there's going to be a pretty significant transition from the way that certifications are done today for recycled materials and what they're going to look like going forward. The idea is that it is simplified, right, for the supply chain. I mean, the supply chain, I think we have certification fatigue because the brands are looking for X, Y, Z, and then the next best thing. So I think the goal is to really bring it together under one standard that the industry agreed upon. So I think we're moving in the right direction, but it might be a little painful in the next couple of years as we transition from one to the other. Also circular systems, and because of EPR regulation in California and what we know is going on in Europe, and what we believe is going to eventually, I would say in the next 8 to 10 years, that is, the circularity of textiles will be required. And I know the mattress industry is very keen to this. I know Connecticut, and there are a few other states that don't allow landfill mattresses. So the design for monomaterials, the design for recyclability is a massive impact to what I know this industry is enduring. And so understanding the materials that are being introduced and that they're recyclable, I think that's a huge key component, because the companies that are investing millions and billions of dollars around the world to basically stand up these chemical recycling facilities that are going to be able to separate cellulosics from man-made and separate those waste streams and really depolymerize those man-made polyesters and other synthetic materials. How are they going to deal with spandex and the elastomeric family of fibers? That's a whole nother conversation. And then how do they deal with fluorocarbons and PFAS and chemistry? Because when we're looking at recycling materials, we're not recycling what we're producing now. We're recycling what we've had in our closet for 10 or 20 years and furniture that's been in circulation for decades. So those materials may or may not be up to today's safety standards as it relates to chemistries. They probably aren't, right? And so the chemical recyclers have a big job of creating a process that will essentially extract the toxic chemicals and really and contain them. And what do they do with that waste? That the APA is hugely involved in this conversation, but there's a lot of work being done in this space in the United States, a tremendous amount of investment. A lot of the European companies are leading these investments, but in the United States, there are as well. So a lot of work being done in the background. And if you would have told me 5 years ago that we would get to a point where textiles would be mandated to be recycled, I really wouldn't have believed it. I'm like, it's not ready. We're not ready. There's no infrastructure. You can mandate something to be done, but if there's no infrastructure behind it, then that work is really null. It's not going to make an impact. But I do believe that we are getting closer and closer. And they may have to push back that 2028 or 2029 date, but I don't think they're going to push it back a whole lot more. So designing for circularity is key.
So we have a few questions that you guys were wonderful in sending in questions ahead of time. So we do want to make sure to have time to address those, as well as any new questions that have come up in the room. So Cheryl's going to start. I'm going to ask her what questions she's going to answer, and she's going to ask me what questions that I will answer.
Great.
Just so you know, we're going back and forth.
So we were talking in terms of the challenges around promoting sustainable and eco-friendly production and the use of those textiles.
I think the question is about hemp.
Oh, okay. Well, you'll address that. You'll talk about hemp.
Yeah, so somebody put in, where are you seeing the hemp fibers and other sustainable eco-friendly yarns used in the industry and perhaps combined with Tencel? What is the biggest challenges for developing and promoting sustainable, eco-friendly production and use those textiles? There really is no barriers. It's out there today. It's being used. It's meeting, your residential double rubs. The other thing I was going to mention when we talk about supply chain, both of these technologies, obviously our fiber is global. Every mill across the globe knows how to use it. Whereas in the Cyclo, that supply chain is also there because we know so much upholstery fabric comes from China, Turkey, India, Pakistan, and those mills and those regions are already being educated and trained of how to utilize and extrude their technology as well as using ours. But back to hemp. So I just want to talk about the supply chain is really already there as well. So hemp is an interesting grown product, takes very little water, grows like a weed. When you use it on your own and try and make a fiber out of it, it's coarser than what linen is. So That is why you will see linens and hemps blended with tencel, because we bring the softness. So they would cottonize, which means staple cut the fiber, whether it be linen or hemp, and then spin it with a carrier fiber that offers the softness. So that's where tencel would come in as far as bringing that softness, easy care to the hemp arena. A separate part of how we've used hemp is, as I mentioned, we're a blend of hardwoods. We have also run trials using hemp waste. So this is not the part that would be turned into staple. These are like the little branches and whatnot, where somebody's broken it down to a cellulose pulp, blend some of that hemp pulp with our wood pulp at, I believe it was about a 15% ratio. So that's another way that hemp can be used as a cellulosic additive for using less trees. So it's another way to look at it that way. But hemp it's important. The industry it's under mature. That's why it's expensive. And as soon as we get more adoption, then prices start to come down. So that's the answer on hemp. It's important. It's similar to linen. You need something to blend it with to make it a little bit softer. And that's where we come in.
I think also our company is a spinner. So we've spun a lot of hemp from the beginning of its development, and it's definitely come a long way. Hemp is just extremely coarse, and it doesn't spin well, and it has very little fiber-to-fiber cohesion. So in a spinning environment, it has to be carried through another fiber, like a man-made cellulosic or cotton, for instance, to really carry it through. So I think, that 15% blend is a good spot for it. 100% hemp would feel like sandpaper on your skin. So I don't think we're ever gonna get there. But it is very sustainable. It's a 2-crop rotation a year, whereas, as we know, cotton is a once-a-year crop. And so you can use, it has a much higher yield per acre of land.
Okay, I'm going to ask you these questions.
Okay.
And we are
We're okay on time?
We're okay on time.
Okay.
How are brands evaluating long-term durability versus biodegradability in upholstery applications?
Absolutely. Durability is number one, no question. Design, color, what we've seen in this building as well as other showrooms this week is really beautiful. And it's so exciting. Yesterday, I don't know if anyone was here at the trend discussion, but because our society is moving more towards AI and fast and automation, I think as human beings, we want to retract and we want to find our safe space, our place where we can call home and be calm and rejuvenate, right? And so the wellness, one topic, I walked away from that chat thinking wellness is the new luxury. So biodegradability falls under wellness, because if we're working with synthetic materials, we know that they're going to shed microplastics. And therefore, if we can get those synthetic materials to biodegrade like natural fibers, then we have actually solved for that issue. So I think in terms of striking a balance, making sure that the materials are durable and they have the performance that you require, but yet have the ability to biodegrade at their end of life, I really think that's an unlock for this industry.
So you have the next one as well. So the question is about validating biodegradability claims on polyester and nylon-based materials. But as I mentioned, just on the man-made cellulosic side, there's TUV Austria is the globe's leading study certification body for biodegradability. So that's where Lenzing comes in with their LCA and their certifications. So that we have, ours are a little bit easier, shorter in time as far as their tests. But Cheryl, can you tell us what goes into on the polyester and nylon-based side?
Yes, biodegradability and testing for it is an incredibly complex topic. When you take a fabric and you would apply a moisture management technology, you can test it. It either passes or fails, right? And you know within an hour of the study, yes or no. In terms of testing for biodegradability, the test can take 4 years, truly. There is not a way of speeding up nature. You simply can't, right? So the test methods that are available to us today, which are ASTM methods, ISO methods, are there to simulate, mimic a natural environment. But that natural environment is its natural environment, right? And so it's incredibly expensive. One study could be $40,000. To give you a perspective of where we believe that making sure that the efficacy of the cyclo technology is incredibly solid. We have over 100 different biodegradation studies. We've spent millions and millions of dollars in testing to confirm that our technology, number one, fully biodegrades. So the cyclopolyester fully biodegrades. There are no microplastics remaining. Number two, the toxicity that remains, right? If a product biodegrades, but it leaves behind toxic soil, toxic seawater, we're moving in the wrong direction. So we have proven through our long-term testing that the environment, and by environment I mean seawater or soil, for example, or even landfill, that exists after full biodegradation does not contain any toxicity. And number three, what happens to those microbes? Because those microbes are digesting the chemistry that is polyester. And so we have proven, we have an incredibly, it's not nighttime reading, let me tell you that much, but it is publicly available and we will share it with you. A peer-reviewed scientific document authored by the Director of Biosciences with Intertech, based in Mumbai. That's where Intertech has their Center of Excellence for Biodegradation. This woman is a bioscientist, microbiology. She is smarter than me, for sure. And she has studied the behavior and the composition of these microorganisms after the process of biodegradation. So it's incredibly transformational. So totally safe, totally proven, and I think that's where we need to end, right? That's where we need to get to. And I'll caution you, there are other technologies in the market, and as supply chain and design and engineers in the room, it is incredibly important that you ask questions and you request all testing, all verification, safety components, that you really vet any technology, as I'm sure you do, that comes your way. And if it's not fully buttoned up, word of caution. There are other technologies that compete in our space that they hand you a document, oh yeah, it's tested at 300 days and therefore it's gonna do X, Y, Z. That is totally false. No one can predict nature, and we know that, right? So we have to see these tests through full biodegradation, where they're collecting the off-gassing coming from the process of biodegradation to have factual data. So I think that's very important for us.
I got another one for you,
Okay.
And I think we covered this a little bit. It's about the how is cyclo technology being positioned with respect to the EU digital passport and traceability requirements.
Yes, we touched on that a little bit, but because of its tracer, we can detect it in fiber form, we can detect it in fabric form, and we can also detect it in finished product form. And so it is the indisputable proof that it is present and that it works. And that's what you're going to need for the digital product passport, if some of you are familiar with that. It's going to require, let's say that you are a furniture manufacturer, let's say a furniture retailer, you have to have every single component of that product totally traced back to the tier 4. Who made the yarn? Who made the fabric? Who constructed the product? It is a daunting task. There are companies out there that are trying to make it easier for companies, but in reality, that's coming, and because Ciclo has a tracer that can be detected at all stages of the product, we're ready.
Yeah, and Lenzing being an Austrian company, we're heavily tied into the EU regulations, the digital passport. We're part of the consulting group that they ask for some of that information. So most of these companies are ahead of it. You think about the big companies like Adidas or Lululemon, people who sell globally, they are really being impacted for this because they sell in Europe. So even though they may be a US company, they're getting educated on this as well.
I think every company, whether it's apparel or home furnishings, it's quite taxing to be able to get ready for it, and everyone's in the same boat. So I encourage you to attend any type of educational session as this develops, because it's going to impact every company. I have a question for you.
All right.
Are there measurable life cycle assessment comparisons available between conventional synthetic fibers and biodegradable alternatives?
Absolutely. So for Lenzing, we have a very strong sustainability team. We are leaders in what a sustainability report looks like. So through doing that and to be able to make all those claims, we do the Higg index on our fibers. We do compare, and an LCA, which is cradle to gate, because we can't be responsible for what happens after somebody spins it or what they put with it. So we speak to just our fibers. And one of the comments as far as EU regulations, we adjusted our claims and we post them on our website, which is what's going to be important for the EU regulations. So us being an Austrian company, we've already taken that step further. The customer can see the claims, they can see the supporting documentation on our website at any given time. So that's some of the things that you might look out for when you evaluate technologies. Is there information readily available? But yes, we have LCAs. We have comparative to generic cotton, generic viscose, polyester, et cetera, for looking at numbers.
Another one for you, Walter. How do these materials perform in high-use hospitality and commercial applications?
Right, so Tencel is a man-made cellulosic. It operates like a natural fiber. So the comparisons would be to any cotton, any linen. Wool's pretty strong, but it'll perform the same there. And the challenge is when you get into institutional, it's 100,000 rubs is what they're looking for, or 70, greater than 50, which is difficult in natural fibers. So that challenge is not going to be any different. But then you can think about, how do you want to use it? You know, a nice chenille accent yarn in a jacquard to give it a little pop. You may want to use a rayon to really deliver that look that you want in the end fabric. So it'll work for commercial. You just want to build your fabric where it meets the rubs and durability. But anything residential, no issues whatsoever.
In terms of Ciclo, there are two uses that I think are relevant for this topic. Number one, there are the VA, some of the VA hospitals actually have sheets currently in use that have Ciclo polyester. It's a blend between cotton and polyester, Ciclo polyester. And we've passed all the requirements, and it's performing really well. That actually went into the market about a year ago. And the other one I can think of is in the uniform industry. As a matter of fact, Ciclo polyester, its first application was in McDonald's uniforms, believe it or not. McDonald's is, believe it or not, very concerned about sustainability in what they procure. So whether you're selling them beef patties or plastic cups or uniforms, they challenged their suppliers to bring sustainable ideas to the table, and they were one of the first adopters of cyclopolyester in their crew uniform. And it passed the 100 industrial laundry, as well as companies like Cintas and others. So it's fully durable, no questions in that regard.
So we're going to need to switch gears from the rest of the questions. Whoever wrote these questions, if you're here and you want the answers to the others, just come up and see us afterwards. But we really, right now, want to open it up to the room. If anybody has excellent questions, you knew where it was coming. So we're going to start here.
So my question is the other end of it. I remember 20 years ago recovering from delivery, and there was something on Today's Show about things burning quickly. Fast forward 20 years, I was as a firefighter, went out on the fire and said, couldn't understand why it burned that quickly. What's being done about burn times and these materials?
So we've done the California test on our fiber specifically, and it meets in the smoldering test. I think it's Cal 117 or something is the.
I just know,
So.
he came back and he said, we got to get out here just a minute later. It would have been worse than the floor before the level. It's the fibers of a lot of the synthetics that's just jumping from place to place.
Yeah, well, as far as the man-made cellulosic, we're pretty good. We also have an FR version of our fibers that firemen use in their baklavas, et cetera, when they go in to fight a fire. So we're very familiar with that. Mattress industry is also very important as far as the burn flame, that it doesn't pass and you're using materials or fire retardant socks on your foam, et cetera. Foam is a big igniter in things. So those foam mattresses, thank God they're putting fire retardants over it. But it's really about how you're making the product, the hairiness, the other things that could lead to catching flame. So it's not really at the fiber level.
There are many different types of fire retardant chemistries that are applied on the fabric. Traditionally, the most commonly used fibers for fire retardation are the modacrylic, in the modacrylic family, the no melt, no drip type of fibers. Polyester doesn't fare well when it comes to fire retardancy. Therefore, they have to have a very strong application of an FR treatment. And there's a lot of safe chemistries out there specifically for polyester. Now, nylon particularly is used very much in military applications. For example, our company spins all of the war fighter uniforms that are worn by our U.S. military. We spin the ripstop, the yarn that goes into the ripstop fabric. And the design, the specification by the U.S. government, there is no wiggle room, and everything has to be tested to the nth degree.
And then we'll go to Sue back there. Hi.
Let me get this microphone to you.
Hi. I'm just curious, when the polyester fiber biodegrades, what does it become?
It becomes basically two things: carbon dioxide, or if it's if it's what they call an anaerobic environment, which is like a landfill, basically anaerobic, the absence of oxygen, then it releases methane. But that's for anything that biodegrades. Let's say, our trash goes to the landfill, and those banana peels and whatever,
Compost.
apples,
Methane and CO2.
biodegrade, they release carbon dioxide and methane. What remains is called a biomass, and those are really elements. Those are going to be nitrogen, oxygen, and natural elements like that. So there is nothing toxic that really is generated from the process of biodegradation.
So the petrochemical disappears?
It is a chemical reaction. So basically, the oxygen and the carbon, if we think about all living, anything that is living, carbon, it's its natural base. When the microorganisms are seeking out their food source, because obviously they're also living, although they have a very short life, they're seeking out carbon. They want to metabolize it, basically absorb it, and their body uses it to live. They're seeking out carbon. Everything else around it, the oxygen and all of the other elements, essentially, are transitioned into the biogases, which is methane and carbon dioxide.
Oh, one more question that's very interesting. Has this technology been tested in polyurethane foams?
That is a great question, and one that we want to find an answer to. Unfortunately, we've been in the research area, specifically in polyurethanes. Unfortunately, polyurethane, the process that produces a polyurethane it's a chemical reaction, and the cyclotechnology ingredients are little biopolymers, are super safe. Unfortunately, they don't survive the process of creating foam. And so we've gone back to the drawing board to see if there are other polymers that we can bring in that are compatible with our technology so that we can create biodegradable foam. But we haven't cracked that one yet. But it's on the list.
Any other questions? There we go.
Hold on.
Are there any textile exhibitors here that are using this technology? And how can we identify them? Do you have a list, or do they have the symbol in their
Yes,
booth?
in particular, Weavers Textile, but we can give you a list of those that are here.
Okay, and then
Yes.
the second question, we know sometimes it costs more to do the right thing. How does this technology increase the cost?
It is very minimal. When we first took it to market, we we didn't want to be a niche technology. We wanted to, number one, create a globally accessible technology that any manufacturer of any textile, whether it was home furnishings or apparel, could adopt, and adopt affordably. So I'll say this, our leading adopter is Target, followed by Walmart. It's very affordable. It really depends on if it's a cat dye yarn, or if it's a special yarn that has a higher cost. The Cyclo typically will add somewhere between, let's say, 20 to 25 cents per kg. So by the time you take that through an actual product, you're really looking at single-digit pennies in terms of the cost.
Thank you.
By the way, it's dosed in at 2%. So out of, when you're making the polyester, you would, let's say you're making a recycled polyester, you would do 98% recycled polymer, 2% Cyclo. So that's all you need to allow that to have the accelerated biodegradation. So the economics had to be there for us. We started at 5% dosing. And sure, we got under 2 years biodegradation, but then it was just too expensive. And we as a manufacturer, we knew the cost pressures that a supply chain has. Thanks for asking the questions.
Are there any other questions? One more. Great.
Oh, hi.
Oh, we have two. We'll do two quick ones.
Mine will be really quick. Oh, I didn't hear you. Okay. I kind of wanted to piggyback off of her question regarding the burn rate as it relates to theaters that are using the polyester curtains,
Yes.
things of that nature. So what are you recommending because of the fire codes and things of that nature for even home theaters because of that, a lot of the issues with the home theaters that are being built?
That's a
more
great
so now.
question. And I think, a lot of times the velvet or plush type of pile fabrics are used for those applications. The challenge with those pile fabrics is they ignite faster. They have more surface area for the fire to take hold. So I would love to do some research on your question. I don't really have an answer off the top of my head. But a lot of it relates to the finishing chemistry that's applied to those fabrics to delay the ability for them to ignite. But I'm not an expert, so I want to take the time to do a little research and get back to you.
And there's always the option to do tencel and cotton for a beautiful velvet curtain. It brings that polyester look. Because cotton can tend to be dry in a velvet, it really mimics the polyester look using tencel and cotton.
So you talked a little bit about just blending with fire retardants and things like that. And my question is about blending other topicals to the fiber, whether that be for other kinds of durability or flammability, and then also how blending other fibers with, so if you have 50% polyester with a cyclo blended with a tencel or a cotton or a hemp or whatever natural fiber that people are looking for. I know that affects a lot of the recyclability. How does that play into the biodegradability of something added with the cyclo? Or if it's another synthetic would probably be a better question.
For example, there's some linen. For instance, if you take like a linen and a tencel and a cyclopolyester, then you have a fully biodegradable material.
Too easy. What if it's
easy.
What if it's a nylon or a
Nylon?
olefin? What if it's an olefin?
Yes. So then it would have to be a cyclonylon or a cyclopolypropylene in order for it to be able to biodegrade. So it would have to have the cyclo technology in it, which we have formulations for all of those polymers.
Right.
But if
for the olefin.
let's say it's an acrylic, for instance. Acrylic is not biodegradable, and we haven't, very similar to the urethane, we haven't found a solve for acrylic either. In that case, the acrylic would not biodegrade. Same thing for the spandex. If there are any type of elastomeric properties, not necessarily in home furnishings quite as much, but that's a real bugaboo for the apparel industry because those are not biodegradable either.
So what about, there used to be a no-no list, like nylon, acrylic. What are the high offenders from the synthetic fibers? So what fibers or what, you said you can't do acrylic, you can't do spandex. So
spandex. Polyester. You can do polyester.
Okay.
You can do nylon.
Okay.
Polypropylene, polyethylene.
Okay.
And those are the four, I would say, polymer families that we have available with Cyclo.
Okay. And then you'd mentioned 2% is the
dosing
amount,
rate.
Right, of Cyclo. So is that, how much of the blended, if I'm looking at a fabric, I'm an interior designer, so I'm looking at a fabric to specify for a sofa or something.
Right.
How much of the Cyclo element has to be in, so if it is 50%,
Right.
of a cyclo polyester and 50% recycled polyester without cyclo, how does that affect the biodegradability rate?
Exactly. So
Does it still biodegrade? Does it take longer?
the cyclo polyester would biodegrade. The recycled polyester without cyclo would not biodegrade.
And then how does it affect the total structure of the piece, right? So if it's made of a lyocell fill, and then it's 50% cyclopolyester, or cyclopolyester, and 50% standard polyester or some other nylon that can't be treated, and every other part of the piece of furniture is biodegradable. It doesn't have any formaldehyde. It doesn't have toxic glues and all those things. How does that decompose as a package?
Really, everything that's biodegradable in its inert capability would biodegrade. The materials that are not biodegradable, they would remain. So it doesn't help other non-biodegradable materials biodegrade because it has to be at the real molecular level. Exactly. The way we see it, however, though, is incremental progress, right? If you can sometimes it's daunting as a designer. Oh my gosh, how can I make this entire product biodegradable? Well, you just start with maybe the most impactful component, and then you add to the assortment. And that's how we've seen the brands incorporate Ciclo is, let's start with the fleeces, with the fabrics that are the highest shedders, the plush blankets, the velour fabrics, because even in a furnishing, you can rub your hand against that, real high pile of fabric, and you can see that it releases microfibers to the touch. So starting with those highest offenders, I think, is always a great place to start. And then over time, you can make it better and better.
You said something also about the percentage of the Ciclo that needs to be in it.
Yes.
I know you said 2%, but at the beginning you said something else. And was it 2% that you were referring to?
2%. So
Okay.
you would introduce, let's say if it's you're making a recycled polyester Ciclo, you would have 98% recycled bottle flake and 2% Ciclo additive. Yes, and then it becomes 100% Ciclo at that point.
Yeah.
So then let's say you're creating a fabric that's a 70-30. Let's say a 70% recycled Ciclo, a 30% tencel, then that fabric then is fully biodegradable.
Some of the examples, you're talking interior design, so you're also concerned with what goes inside.
Right, and I know lyocell is a big fill for a lot of manufacturers right now.
Yeah, and that's where we worked with some major Indian manufacturers and Pakistan manufacturers for building pillows, like a bed pillow where the fill is Ciclo and tencel. So you have the comfort attributes, you got the biodegradability of both of them, you got the performance of loft from the poly side, and then the fabric, we did the same thing. So it's a easy care, cool to the touch, soft fabric, but performance, low wrinkle because of the polyester. So building your fabrics and keeping those materials in mind, sometimes you may not be able to get away from something that's on the bad list because of the aesthetic that you want at the end of the day. So just knowing what your options are in what you're trying to build and going from there, it's more improvement than what it is today.
Exactly. And from a fill perspective as well, Ciclo is produced today quite commonly in fiber fill. So there's product in the market, for instance, in duvets and pillows and deck pillows.
Anything other in seat cushions besides the lyocell? Does Ciclo have anything like
I think
Dacron, foam, anything like that?
Not on foam. I think we're running against the brick wall on the foam there, but hopefully we'll be able to crack that one in the next few years.
So when the microplastics are exposed to our bodies and they have the Ciclo in it, has there been any testing on the Ciclo and inside the human body
What
and the
happens?
effect on us?
There is medical research that's just now initiating that is going to be able to answer that. We don't know the answer to that quite yet. I will say that the ingredients that compose the Ciclo technology are 100% safe. As a matter of fact, one of our ingredients is in toothpaste today. So they are safe, free from any harmful chemicals, what we use in our technology. So it's really, what does the human body do? And typically, they have to, in order to cross into the blood-brain barrier, they have to be at the nanoplastic level. Primarily the polyester, let's say the synthetic materials that we would ingest either through drinking water, let's say through drinking water or seafood, they would mainly just extract through our normal waste system. They would not be able to cross the blood-brain barrier. So there's just now research that's starting to understand what happens. So we don't have a lot of answers quite yet. Here's where we believe the Ciclo technology is transformational. Rather than polyesters remaining in the environment for 100 years, 200 years, and the opportunity or the possibility for the body to ingest them is much greater when there's just this accumulation that's taking place every year. With our technology, we immediately, after 4 years, it's fully biodegraded. So it reduces that pollution and the concentration of that pollution so that there'll be less microplastics that have the opportunity of making it into our bodies. It's the beginning, really, it's the beginning of science when it comes to textiles like this. And we're committed to being responsible textile manufacturers. I'd also like to share we're speaking at the federal level to present our technology to the federal government so that they understand that, hey, the textile industry and the industries are out there doing research. We're trying to solve the problems that exist. And it's really encouraging. We've actually seen a lot of different companies out there dedicating a lot of money to the research of solving these things.
And one thing that we didn't mention is, ours is Okotex 100 certified for our fibers. And I just learned today about the different Okotex certification for chemistry, which...
Yes, chemistry has a different certification. It's called Eco Passport, and it tests for the safety of those chemicals that are a part of the fiber. That then, for instance, when it gets extruded into a polyester fiber, that fiber would have to be standard 100 certified. But because it uses the cyclochemistry, it's Eco Passport certified. So it just kind of wraps under the Eco Passport certification. Great questions.
Yes. Well, we want to thank you all for attending. I loved the early questions when you registered. That was outstanding. And again, if there are some that we didn't answer and you want to catch us afterwards, feel free to. But again, thank you for coming to Interwoven and supporting the industry with what you do.
Thank you so much.